Mutual Induction Introduction by Madam Rosmaya. What is mutual induction? Mutual induction is the phenomenon in which an e.m.f is induced in a conductor when the current in a neighboring conductor changes. Observe these two simple circuits. The conductor we use here is a solenoid. The first circuit, which is the primary circuit, consists of battery, solenoid, switch and a resistor, whereas the secondary circuit consists of solenoid and a voltmeter. So we are going to discuss the process of mutual induction at the moment the switch is on and also at the moment the switch is off. So before that, we are going to discuss what happens when the switch is on for a longer time of period. For a longer time of period, the current will become steady in the primary circuit, and the direction of the current is from terminal positive to terminal negative. Therefore, the direction of the current in the solenoid will be downward. Using right hand grip rule, the four fingers follow the direction of the current in the solenoid, which is downward. Therefore, the thumb shows to the right and the B node means this is the direction for the B node, magnetic field of the first solenoid or primary solenoid. The B node is constant, therefore no induced e.m.f in the secondary solenoid. From the formula, magnetic flux equals to NBA. If B constant, therefore there is no change in the magnetic flux linkage. And from Faraday's law, if there is no change in the magnetic flux linkage, no e.m.f is induced in the solenoid, secondary solenoid. At the moment the switch is on, the direction of current is the same in the solenoid, primary solenoid is downward, but the current is increasing. Using right hand grip rule, the direction of B node can be determined, which is to the right. But this time, if the current increasing, B node also increasing. From this formula, B equals to mu node and I, so I increasing, B increasing. From formula, magnetic flux equals to NBA. If B increasing, magnetic flux also increasing. This means there is a change in the magnetic flux linkage. If there is a change in the magnetic flux linkage, from Faraday's law, e.m.f is induced in the solenoid, in the secondary circuit. So what is the direction of the B induced in the secondary circuit? So according to the Lenz's law, the induced e.m.f opposes the increase in B. So the B induced must be in the direction to the left direction, because the resultant of these two will be decrease to oppose the changes. So increase in B, the resultant will be decrease in B. And to determine the direction of current in the secondary solenoid, using right hand grip rule, the B induced is to the left, shown by this thumb, and therefore direction of current is upward. Refer to the other four fingers, so it's upward. And the direction of the two direction is opposite each other, direction of current. So therefore the pointer of the voltmeter is to the left. Next, we discuss the phenomenon of mutual induction at the moment the switch is off. When the switch is off, again the direction of current from terminal positive to terminal negative. So direction of the current in the solenoid is downward and current decreasing because the switch is off. So direction of B node is to the right. using right hand grip rule. If the current decreasing, the B node also decreasing. By the formula B equals to mu naught and I, so I decreasing, B also decreasing. And from magnetic flux equals to NBA, if the B decreasing, so there is a change in magnetic flux linkage. And from Faraday's law, if there is a change in magnetic flux linkage, e.m.f is induced in the secondary solenoid. So next we are going to determine the direction of the B induced in the secondary solenoid. So using Lenz's law, induced e.m.f opposes decrease in B. So the B induced must be in the direction to the right, so that the resultant will increase. So to oppose the decrease in B, so the B induced must be to the right, so that their resultant will increase. Next, the direction of current can be determined using right hand grip rule. So the B induced is to the right, so the thumb shows to the right, and therefore the other four fingers shows the direction of current in the secondary solenoid downward. And compare the two direction of the current, primary solenoid and the secondary solenoid is the same. So therefore the pointer of the voltmeter will show to the right. To change the current, we can use rheostat instead of switching on and switching off the switch. So this is primary solenoid and this is secondary solenoid. So a current I flow through a solenoid P, primary solenoid. A magnetic field is produced in P here, in the solenoid P. This field is a link with solenoid Q, and the resistance of rheostat is varied. The current I in solenoid P changes, and therefore the magnetic flux link with coil Q also changes. Then from Faraday's law, an e.m.f is induced in secondary solenoid Q. So the pointer here will keep on changing to the right or left, depends on how we varies the resistance in the rheostat here. Okay, instead of using rheostat, we also can use alternate current. So the changes in current in the primary coil will change the B, and also from Faraday's law, because of there is a change in the magnetic flux linkage, therefore the e.m.f will be induced in the primary circuit, primary solenoid here. And the mutual induction process will be forever. Okay, the working of the transformer is based on the principle of mutual induction. In the previous example, the two solenoids is arranged next to each other. In this example of transformer, the solenoid is arranged on top of one another. We can also arrange like this. The solenoid, the coil or the solenoid is wound on top of one another like this. And the mutual induction is the basic operating principle, not just in transformer but also in motors, generators, and any other electrical component that interacts with another magnetic field. And therefore we can also define mutual induction as the current flowing in one coil that induces a voltage in an adjacent coil. The end.